In this video, we'll be learning how to write equations and inequalities. To start, I want to share my thought process for setting up word problems. One of the very first things I do is identify the number of dimensions I'll be working with. Kind of at the same time of figuring out if I'm working in one dimension, like distance, two dimensions like area, or three dimensions like volume, I'm also going to be looking at what type of units do I have. Am I dealing with typical units of measurement, like the English system or the international system? Most of you probably know that as the metric system. Or do I have something that's more like a description of the values? Population, apples, jars of peanut butter, I don't know, just a description. From there, I can determine what operations I'll be using. If all of the units are the same throughout the word problem, I'll be adding and subtracting. If any units are different, they'll be multiplying or dividing or both, or there's going to be multiple different operations involved. From there, I'll go on to write a statement and use the properties of operations as a guide. A lot of the times in word problems, the numbers don't appear in the order that you set up the problem in, so you'll have to be kind of using those properties in accordance with the word problem. And last but not least, we'll figure out how many answers we need. If there's one or two exact answers, we'll use an equal sign. And if there is a range or multiple answers, we'll use the inequality symbols. So let's look at an example. Catering company rents out tables for big events and parties. Their tables can hold up to 8 people. And if we're having a school celebration for graduating seniors, their parents, and staff, what is the minimum number of tables needed for 243 people that have RSVP'd? Like I said, I look at the number of dimensions and units all at the same time. So I have tables holding 8 people and 243 people. None of those terms are squared or cubed. I'm going to assume that these are one-dimensional units. I have differing units. So I know that I'll be multiplying. A while back, I'd mentioned that we are going to set up all of these problems as if we're multiplying or dividing, sorry, not dividing, as we're multiplying fractions or ratios. So then what I look for is how am I going to set this up? I have 243 people. Since this one is by itself, it's the one I want to start with, and I'm going to put it over 1. And I want to end with tables. That means people have gots to go. 8 people here, 1 table there. Last but not least, I just need to figure out what sign do I need to use. To help me figure that out, I'm going to focus on this word right here, minimum. Especially right now in the time of social distancing, this number of tables will probably not be the ones that we order. We'll probably order more. And as that is the case for this problem, the number of tables has to be greater than or equal to whatever this minimum number is. We won't worry about solving these problems just yet, just setting them up and going through this thought process. Let's look at another example. The population of country A is approximately 1.53 times 10 to the 6th. The population of country B is approximately 1.2 times 10 to the 7th. How many more people live in country B than in country A? population and people are pretty much the same. So I'm going to say that all three of these units are the same and they're all in the same dimension. I'll say it's one dimension. We have the unit of people. How many more? And we're comparing B to A. This tells me that we're going to use subtraction. And this one actually tells us in order. We're going to do B, then A. So the population of B is 1.2 times 10 to the 7th. And for A, it's 1.53 times 10 to the 6th. In this situation, it makes sense that there's only one possible answer, so we'll use the equal sign. If you need to pause and watch that again and pause multiple times to process what was going on, go back. Next up, we have example 3. Lana picked 36 tulips and 37 roses to make bouquets. If she ended up using 70 flowers, how many extra did Lana pick? So we have tulips and roses. This bouquets may or may not be important. And we have flowers. The first thing I notice is there's no squares or cubes. We have one dimension. But I can't tell if we have different units or not. We have this bouquets, tulips and roses and flowers. But if I treat these together, these are flowers, right? And I want to know how many extra did she pick. That tells me bouquets isn't important. We have flowers and flowers, so these units are going to be the same. And because they're the same, we want to know how many extra were picked. We have subtraction. Which is a little misleading, right? Because what we haven't done yet is combine these into flowers. So we have to do both, add and subtract. And once we do that to get total flowers, we would set this up as 36 tulips plus 37 roses. That'll give us flowers. And we're going to subtract 70 from that amount. There's only one possible answer, so we have another equal sign. And then last but not least, example 4. The Barclay family is trying to decide if they want to replace all of the carpet in their living room, part of it, or none of it. The living room has a length of 20 feet and a width of 13. What are all the possible amounts of carpet they could order? At first glance, this looks like it's one dimension, feet and feet. But this problem is going to assume that carpet is ordered in square feet or in some places square yards. Because that's assumed, this tells me that we are working in 2 dimensions. My units are going to be different. I'm going to have to multiply. And then we have to set it up. I know we're going to have 20 feet times 13 feet. But what does that mean? If we have this 20 feet times 13 feet, that would be if they wanted to replace all of the carpet, right? So this would be all of the carpet. But it also says part of it. So anything that is part of, it's kind of in this middle area. I'm just going to put a box here. Or none of it, which would be 0 square feet. this tells us that we have an inequality, but it also gives us a range. If we want all the possible amounts, the amount of carpet can be equal to all of it, or it could be less than it, but it has to be greater than or equal to 0. We can't order a negative amount of carpet. That seems silly to say out loud, but that's why we end at 0. And that is how we would set up word problems using this method. That's all for today. Thanks for watching.